Alright, hey guys, it's Cheng again. If you're not sure whether I am Cheng or not, sit down, shut up. So it's authentic Cheng. Hopefully the last video you found a little bit helpful in understanding exponential functions, so we'll continue. For this video, we are going to talk about the transformations of exponential functions. As I mentioned before, you can run, but you cannot hide from transformations. So we did transformations already. I hope this is a good review for the transformation stuff. If you have not written the test yet, and even if you did, well, this would be a good preparation for the stuff for today, and then in the near future, when we talk about transformation in the trig unit. Alright, so the first thing I would like you guys to do is to look at the formula sheet. So if you look at the formula sheet, this is the general formula for a transform function. So a, b, h, and k, and of course in front of a and b there would be minus sign to indicate reflection, so we will come back to those in a second. And also at the same time, look at this growth or decay formula for exponential function. I wrote this down in class. We are not talking about this form at this point, so this is a general formula for a growth or decay formula for exponential function a times b to the x. So these two are literally the same. As you can see, a, b and b, except instead of having exponent of this form, we just have a general exponent in the form of x. Alright, so now let's go back to the notes for today. So if you look at this, the basic transformation can be transformed from this into this. If you want, we can write down the general form here. Once again, y equals to a, b, x. So let's highlight this so that you can always compare to this one here. Alright, so if you look at this one here, for the form we are looking at, we are assuming that a is equal to 1. So what does that mean? That means you have a y-intercept at 1. I hope this is a review for you. And so let's look at what's going on here for the transform exponential function. So the first thing I hope you guys can notice is, if you look at this, we still have the function, except that for the function we put it as an exponent up here, and then of course after transformation our new function would be up here as an exponent as well, and then the rest, this part is anything related to x, horizontal stuff for the function, and then anything related to y, the vertical stuff, they would be outside of the function, just like the normal transformation from the last unit. So anything related to y would be outside of the function at the front or at the back. But when you put down a and k values, make sure you don't put it up here. Only the function and anything related to x, you put that up as an exponent. Alright, so let's look at which one is which. I hope this is a good review for you. You might want to pause for a second to jot down the notes. A, once again, is the vertical stretch factor, so that means stretching up and down about the x-axis. Alright, and if A is negative, that means it's going to be a vertical refraction. And again, you might want to pause for a second. And B is horizontal stretch factor about the y-axis, and again, whatever horizontal stretch we talk about, stretching sidewise, like to the left and to the right, we write that as 1 over b in our equation. And again, if there is a sign which is negative in front of b, that means it is a refraction, so horizontal refraction. Alright, so on a second thought, I thought perhaps it would be a good idea for me to write down the general formula for transformation so that you can compare the transformation for general function and this one here for exponential function. So y equals to a times f of okay, so a times f of in bracket b minus times x minus h, and then outside that you have plus k. And once again, we want to take out the b thing so that x is always 1. In that case, whatever you see inside the brackets would be just the horizontal translation. Alright, so now let's keep going. So the next thing we're going to look at is, oh, sorry, I know you might have a question asking me, Cheng, is this b the same as this b? No. Okay, so this b is, as I just mentioned, the horizontal stretch factor. It tells you how far the graph is stretched from the y-axis, and this b here is just the base. Look at the example from last day. Okay, so these two b are not the same b, so don't get mixed up. So now let's look at h here. H once again means horizontal translation, and if h is greater than 0, that means it is translated to the right hand side by whatever unit this is. Okay, and then if h is less than 0, that means it is translated horizontally to the left hand side by that many units. Okay, once again, for the horizontal translation stuff, it's going to be tricky. You have to flip the sign, don't forget that. And then last but not the least, so k is once again the vertical translation. So same thing here. If k is greater than 1, that means it is moving to the positive direction, i.e. moving upward. And then if k is less than 0, which is negative, so that means the graph would be moving downward. And then one last thing I want to comment on before we work out some example is the general coordinate change, or something that I've mentioned so many times, which is the mapping notation. Mapping notation. So by the way, most of you did a good job for the transformation assignments, and the answers are already posted on D12, so have a look. And also make sure you still remember how to write the mapping notation and apply and use that, because you will find that it is very, 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 very helpful when we talk about transformation, not just for normal transformation for function, but any transformation that you will see in the near future. Alright, so the mapping notation is x and y. Okay, so this is the original function, and now here's a transform function. So once again, the same thing, 1 over b times x. You may see someone wrote this as x over b instead, the same thing, and then plus h. Anything horizontal is here, and then anything vertical is here, ay plus k. So that's nothing really new here. Alright, so that's a good news. And once again, this mapping notation is not on the formula sheet. Check this out. So this is the one you're going to see on your diploma exam, if there's any. Alright, so now we have covered all 6 types of transformations. Alright, so let's move on to apply the concept and work out some problems.